you're going to fix your house, you're going to have to make a billion difficult decisions.
Yeah.
And most of them are going to revolve. They're going to orbit around what your budget is and what you're comfortable with and what you have accessible to you. So the more knowledgeable you are about the components and how they work together will help you determine where you're going to get the most value for your financial resources. If you can do that by yourself and online, that's awesome, because it makes the whole world better if all of us were doing that. And if not, then we can help you, and there's lots of other really smart people, especially in our town, that can help make those kind of decisions. So
there's a couple people out there that do energy modeling that can do this modeling
sort of
for you.
consulting, architecture.
Yep, for sure. We're not the only ones. And we just know, like, Patrick and I just sort of are like, the more people that know this stuff, the better chance we have of all of our buildings, all of our buildings getting better. I also wanted to say about the Superior Building Envelope. So there's a couple terms that are thrown around that you should know about. One of them is R value. People have heard about that for a long time. That's resistance of heat as it's passing through material. So you want a high R value number. And then there's
another. You want it to resist.
You want it to resist. And then there's another one called U factor. And U factor is the inverse. You want a low number for U factor. And that has to do with windows.
That's applied to
R value usually has to do, it has to do with fenestration or windows. And R value has to do with the walls, the roof, the floor, the solid parts. So there's just like different things about a window compared to just R value, because there's the surface of the window has a certain, what am I trying to say? Resistance.
There's stuff inside of the window.
There's the frame. Some frames are insulated. Like, there's a lot of components that go into a window, so they measure it. They do the calculation and come up with a final number in a different way than just R value.
Why should I care about the walls and roof of my building? Most people understand that. Like, if it's cold out and I walk outside in a t-shirt, it's probably going to suck. And if I just put on my puffy jacket and maybe a rain jacket, it's going to be immediately so much better.
Yeah.
And the reason it's so much better is that all the heat my body is generating is staying with me. It's not going out into the world. And so houses are the same thing. We oftentimes refer to as, like,
put a sweater and a rain jacket.
New sweater and rain jacket is all you need, and everything will be great inside. The whole game of this thing is that we're using natural resources to generate energy. It's precious, right? We want it to be as efficiently used as possible. It's gold to us. And so the stuff inside that's using that power, it has to use it really, really carefully. And the box that we have built, that we're heating with the most, with the appliance that uses the most energy, that is gold, right? We want that heat to stay in that box as long as we possibly can, with the least amount of input to change the temperature.
Well, thermal bridging is the same kind of thing, and everybody has seen thermal bridging without realizing it. We talked about this talked about this the last time we had a Facebook Live. This is a good time actually to go out, because it's that we're going from cold to
warm to cold,
and we got a lot of moisture in the air.
Tomorrow morning,
go out and walk through your neighborhood if you have a lot of houses in your neighborhood, or your own, and look at the siding. And if you see and the roof, if you see lines where there's a difference between dry and wet, or a difference between frost and no frost, you can actually see all the signs of thermal bridging on older buildings. And what it means, you're seeing the heat come through the 2x4 board that is attached to the siding, and it's heating up the siding, and it's drying the siding right where that board is, because heat is going out through that thermal bridge.
Also known as dollar bills.
And so you can stop that heat leaving the building by putting continuous insulation at the end of the board or
Yeah.
on the sheathing.
Between the framing of the building and the siding of the building.
Right. And so it helps to keep the...
It resists the thermal transfer.
Yeah.
Because the inside wants desperately to be the same as the outside, and vice versa.
I know.
They miss each other.
Right.
They're heartbroken. They're just trying to get together.
Yeah. Now here's one, I'm jumping ahead of myself, but here's one that'll really blow your mind. If you've got too much moisture in your house and it's raining outside, and you want to get the moisture out of your house, would you open your windows or would you close your windows?
I think I would be inclined to open my window.
You do. You open your window.
Yeah.
I, for a long time, thought, oh no, you close the window because the moisture is going to come in. But
it's going to come in.
The
moisture inside is more. It wants to be with the moisture outside.
I like
to
to
an okay
leave
relationship with us.